Okay, so welcome all of you. Again, today is a day of introducing next quarter and talking about the exam coming up on Friday. But before we do that, let's go over the quiz. So let me share my screen and we'll talk about the quiz. Okay, so the question is, use Newton's method to approximate the critical point accurate to 3 decimal places of the function f of x equals e to the x minus 2x with the initial guess of x equals 0. Okay, so if we want to approximate the critical point, that is not the same thing as finding the root of this equation. What do we have to do first? And I know some of you got stuck on it on the homework and emailed me, so those you better know because we talked about it. Yeah, the critical point happens when the derivative equals 0, not when the function equals 0. So that's the first step. So what I'm going to do is I'm going to take the derivative of this function, and I'm going to set that equal to 0. So we know that f prime of x is, well, the derivative of e to the x is e to the x. I hope that's easy for you. And the derivative of minus 2x is minus 2. So again, the derivative was not the hard part of this guy. All right, so then what we want to do is we want to set that derivative to what? To find the critical point. So if we have a critical point, what do we know about the derivative? Yeah, we set it equal to 0, and Newton's method is all about finding out when something is equal to 0. Any questions on that? Okay, so now we can use the big formula that I did 2 days ago, and it's in the book and everywhere else. And that says if you have something equal to 0, you take your prior guess, subtract the functions evaluated at the prior guess, and divide by the derivative of the function evaluated at the prior guess. So in particular, let's copy and paste this guy. Oops, missed it, sorry. There it is. So in particular, what we're going to do is we're going to say y now, which is the way I did it a couple days ago. You can call it whatever you want. That's just the next guess. You could use subscripts. It's just more writing if you have to do that. But y is going to be by formula x minus the...
I want to go play in snow, Nora.
All right, I'm going to mute you. If it lets me. Yeah. So x minus the fraction, and then we put f on the top. And then the bottom is f prime. What's the derivative of e to the x minus 2? That's supposed to be easy. Yeah, that's e to the x. Any questions on that? Okay, now you don't have to do what I'm about to do, but it's going to make it easier for a calculation when we're plugging in. And then it's just simplify this, this expression. So we have x minus, oops, let's go equal, x minus, e to the x over e to the x is 1, and that's why it's easier. And then minus a minus is plus, 2 over e to the x is 2 times e to the negative x. Okay, again, it's not necessary to do it, but it's just going to save us some time in the typing out the numbers. Any questions at all so far on getting this kind of what I call Newton's method function, which is y equals x minus 1 plus 2e to the negative x? Okay, then what I'm going to do is I'm going to make a table. And in our table, we're going to have our prior guess, our f prime, and our next guess. So that's 4 different things. And I'll just pop in a bunch of rows. I don't know how many we'll need until we're there, but we'll see. So our first guess, so we have x, f, and let me not call it f, actually, let's call it y, because we already used f. And if we already used it, you should never use it again for something else. Y prime, and then we're going to have x minus y over y prime. Okay, and x minus y over y prime is the same thing again as this x minus e. Let's write this out. Can't see it. Let's try that. That works. There we go. So that's going to be x minus 1 plus 2e to the negative x. So x, by the way, is 0 for the first one. And then our, let's see, maybe I shouldn't call it y and y prime because I call something else y. So how about g and g prime? Never want to use the same letters for 2 different things. That's just standard in math. Okay, and then g, that means we're plugging it in to e to the x minus 2, plug in 0. Hopefully you don't need a calculator for that. That's negative 1. G prime, that was e to the x, and plug in 0, you get 1. And then we're supposed to take 0 minus 1 over 1, a minus negative 1 over 1, which is 1. You good with that? So I didn't need a calculator yet. We will in a minute, though. Okay, now our next guess is x. Now we got to do some work. Okay, and we have f of x equals e to the x minus 2x. So, and just note, this is important, we want 3 decimal places. Okay, because if you don't know that, this problem is too hard to do. Okay, so we want 3 decimal places. So what I'm going to do is I'm going to we need to put in e to the x minus 2, which is e to the 1 minus 2. Calculators are good for that. E to the 1, and then minus 2. And we want 3 decimal places, 0.718. I actually know that one by heart, but I figured I'd show you how to do it. So that's 0.718. And then we want g prime, which is just e to the 1. And that's 1.718. Because remember, it's just off by 2. Sorry, not 1. It's 2.718 is what I meant. Okay. And then we're going to take x minus g over g prime. So we're going to take 1 minus 0.718 over 2.718. Any questions on that? So 1 minus 0.718 over 2.718. And we get 0.736. So then our next guess is 0.736. Any questions so far? Okay, then we're going to take e to 0.736 minus 2. And we get 0.088. And then we're going to take e to the 0.736. So drop the minus 2. And we get 2.088. Okay, then we're going to take 0.736 minus 0.088 divided by 2.088. So 0.736 minus 0.088 divided by 2.088. And you get 0.694. Okay, stop me if there's any questions. It's mostly just calculation, but you got to do it. 0.694. Okay, how do you know when you're done, by the way? Yeah, if we repeat, if you get back to where you started, then you plug it in again, you'll get the same answer always. So now we're going to do 0.694. So let's do G, which is e to the 0.694. And that's 2.002. And then our G prime. Oh, sorry, we forgot to subtract the 2. So it's e to that minus 2. So the good news is we can just drop the 2. And if you don't have the minus 2, then it has a 2. 2.002. Any questions on that? Okay, then we take 0.694 minus 0.002 over 2.002. And we get 0.693. Okay, so we're getting closer. We're almost there. So 0.693. Okay, we need to add one more. I want to insert a row after. There we go. So 0.693. We take e to that minus 2. So let's just do e to that, and then we'll subtract 2 is the easiest. E to the 0.693. And you get 1.9997. 3 decimal places, exactly 2. Any questions on that? So that's 2 here. So subtract 2, you get 0. That's a good thing. That means we're done. So if you plug in and you get 0, that means you found the root to 3 decimal places. So the answer is the critical point occurs at 0. Or let's go x equals 0.693. Any questions on getting this table to work? Any questions on it? Okay, it's a little busy work, but Newton's method is, and again, in the real world, what you do is you program a computer to do this, which is much harder, by the way, because you got to program. So it involves coding. But that's how you do it in the real world. And then you do modifications because, again, if you're going to be a STEM person, that means things aren't exactly as what you learn in calculus. You have to modify for your particular need. Okay, and that happens. So that's why you have to truly understand it, because if you don't truly understand it, you can't modify it. So it's not just about using Newton's method. It's about understanding it so that you can get what you need to get in whatever you happen to be doing. So any questions at all on this quiz?
So just to make sure, when you're evaluating a critical point using Newton's method, in the equation of y equals x minus f of x over f prime of x, really the f of x is the f prime of the thing you're looking for the critical point of, right? And then
Exactly.
the f prime is f double prime of that.
Exactly. So what you can think about it is, it's kind of Newton's evolved method has y equals x minus f prime over f double prime. Does that make sense?
Yes.
Yeah. So I call it evolved method because it's an application of Newton's method and not exactly Newton's method. Do you see how that works? So that's how it works. And it was on the homework. I know that because I had multiple people emailing me, not knowing that you need to take the derivative first and then use that for Newton's method, because it says critical point. Critical point means take the derivative, set it equal to 0. Okay, any questions on that? The interesting thing is I wrote this quiz before I got the 3 emails about confusion. But it wasn't the homework, so I don't feel guilty at all. I think there were 2 problems that had to do this. Okay, it wasn't this exact, e to the x minus 2x, but that wasn't the hard part. I hope taking the derivative was not the hard part, because if it was, you're not passing this class. If this is what you consider a brutal derivative, you're not making it. E to the x minus 2x is an easy derivative. Okay, I hope you all agree. Okay, it doesn't use a product chain or quotient rule. Okay, even power rule. Okay, any more questions? Okay, are there questions about anything else other than the exam? The exam we'll talk about at the end, and I'll take exam questions at the end. Questions about anything other than the exam? Okay, maybe the quiz actually answered some of the questions, because again, I know that I got some questions yesterday about doing the relative extrema instead of finding the function equals 0. Finding the relative extrema means the derivative equals 0. Okay, so now comes a major topic. Okay, obviously we're not spending a lot of time on this topic because our class is almost over and today's the last day of new topic, but this is what you're going to be doing all of Math 106. Okay. So pretty much, I think it is every single day. At least in this class, we had a couple days on just on limits, probably 5 days or so, and all the rest were derivatives. So next quarter is all about what we're doing today. So this is an introduction to next quarter. Okay, and just to note, in the old days, we used to actually have a whole chapter on this, but we had exponentials and logs came next quarter. So there's 2 ways. So if you go on to, if for some reason you don't take next quarter, you transfer somewhere else. If you transfer somewhere else that has what's called late transcendentals, then they're going to expect you to know a chapter of this antiderivative stuff coming into it, but having no clue about the derivative of e to the x. So just and we used to do that, and then we changed books, and now we're doing what's called early transcendentals, which means e to the x ln of x happened this quarter, and then the full, whole 3 weeks of antiderivatives or 2 weeks doesn't happen in this class. So that's just a note that if you happen to, for some reason, doesn't usually happen much mid-year, but if some reason you switch schools, I don't know why anyone would switch schools with COVID. So even if you're moving, you still could take this class. You could still, or Bruce's class, because everything's online. Okay, all you have to have is internet access, which I think you have to have anywhere. Okay, so let me give you the big definition of next quarter. I know that sounds weird, of next quarter, but it really is of next quarter. And it's a intro definition of this quarter. And that is the definition of antiderivative. So let's make this happen. So this is a definition. And it says the following. Let f prime, let's write it as an equation, f prime of x equal capital F of x. Sorry, it's the other way around. Let capital F of prime of x, let capital F of x be the derivative of some lowercase f of x. Okay, and this is standard notation, by the way, is they use capital for the function that's the derivative of something, okay, and lowercase for what you're taking it of. Okay, do I have it right? Sorry, I always have to think backwards. Let little f of x equal, no, it's the other way around. It's what I had originally. Sorry about that. That's better. Then capital F of x is called the antiderivative. Actually, let me not even say that. Called an antiderivative. I know it's like I didn't change anything, but actually I changed a lot. Antiderivative, derivative of lowercase f of x. And let's put this bold and red. Because it's that important. Any questions on this definition? Okay, so let me give you an example. And an example is x squared is an antiderivative of 2x. Any questions on that? Any questions? All right, I have a question for you. Let's see how y'all do. And I want you to all to answer it, but I want you to all give me a different answer and put it in the chat box. So here's the question. Find another one. So I want you to all answer this, but everyone has to give me a different other one from each other. So once someone's put something in the chat box, you can't do that one anymore. So I'll let you think for a moment. And if no one comes up with one, I'll give you one, and then hopefully everyone will get the idea. It's really easy if you know what to do, if you think about it. And if you don't, you won't get it. No, not another example. Another antiderivative of 2x. So maybe I'll put it in more words. So find another antiderivative of 2x. X squared is 1. Can you find another? Okay, find another antiderivative. 1/2 x to the 4th is not, because if I take a derivative of 1/2 x to the 4th, I get 2x cubed. I didn't get 2x. You have to get 2x. So I'll give you 20 seconds or so, because either you think of it or you don't think of it. My guess is as soon as I give it to you, everyone will say, oh, there we go, 2x squared plus 1. Now I bet everyone else can find another one. So see if you can put in the chat box. Good, x squared plus 3. Let's see some more. Good. X squared plus 4 is another one. Yeah, x squared plus 5. X cubed minus 7 doesn't work because the derivative of that would be 3x squared. And 3x squared is not 2x. Good. X squared plus 1258. X squared plus infinity is kind of not quite right because infinity is not a number. I know you're trying to get like sweet, but infinity is not a number, so we just don't go there. Good. X squared plus 7. All right. So hopefully you're getting the idea. And that is that if you take any number, I don't know, how about x squared plus pi over 8? That's also one. Do you agree? Okay. So here's a big theorem. So the theorem says not only does that work, not only does adding a constant work, but it's the only thing that works. Okay, so here's a theorem is let capital F of x be an antiderivative of lowercase f of x. Then every antiderivative of lowercase f of x is of the form capital F of x, and the standard letter everyone in the world uses is plus capital C, where C is a constant. Any questions on the theorem? Okay, it's clear it works. It's clear, hopefully it's clear to you all, that if you take a derivative of capital F of x plus C, then you get the same thing as the derivative of capital F of x. Right? Hopefully that's okay to everyone, that everyone knows the derivative of a constant is 0. We actually had, it was the last time or the time before where we actually had the theorem. I think it was 2 times ago, where we had the theorem that if two functions had the same derivative, then they differed by a constant. I don't know if you remember that, but that came up a while back. So I don't need to prove this because it kind of already was. Okay, but it's really important next quarter. Okay, and in fact, and again, I'm not your instructor next quarter, but if I were, I call it the 1 point C. Do you know why I call it the 1 point C? Because if you forget to write plus C, I take 1 point off of the problem. Even though the problem is really hard and complicated, but if you forget the plus C, you lose 1 point out of 10 usually. So, you know, and that'll get you because plus C is on most problems. So you lose 10% of the grade, and that's not good. So it's real important that you remember that anytime you're looking for all of the possible antiderivatives, you find any one antiderivative and then go plus C, and then you got them all. Any questions on that? Okay, one of the things you may or may not notice is there's a lot of words here. Do you agree? And when there's something really important and there's a lot of words in math, what do mathematicians usually do? Because we're lazy. And in particular, Newton did that. I think it was Newton. It might have been Leibniz. What do mathematicians usually do if there's a lot of words, but we don't want to write a lot of words all the time? And it's the same ones over and over again? Come on, you should know. Yeah, denote things. We make a symbol for it. So here's the definition. And that is, it's there. Yep. So this little thing, which I'll talk about in a second, right? Just like in our class, we had the derivative. It's a whole lot easier to just put a prime after the f. A lot less writing. Well, same thing. It's a lot easier, especially if you're writing on paper, to do it this way. And I want to make it bigger. That's why I'm spending some time. So what we say is the integral of f of x dx is the set of all antiderivatives of lowercase f. Any questions on the way to notate the antiderivative? So it's kind of a funky little curvy line thing. I actually have no idea, why they came up with that. It kind of looks like a summation sign. You're going to learn next quarter why that's important, but I don't know how much it really looks like a summation sign. But that's what it is. So it's a curvy line thing, kind of curves right on the top and left on the bottom, and it looks like that. Okay, and it's called the integral. Okay, and in fact, next quarter, the title of the class really is Integral Calculus, because it's all about integrals. Okay, and you're going to be using this notation every single class period next quarter. Okay, that's a guarantee. So that is really important to get for next quarter. Everything I talk about now is all about next quarter. Okay, you will have probably one problem on the final with a antiderivative, but it's a small part of our class. But next quarter, it's the class. Any questions on this idea? Okay, so with derivatives, by the way, are there any functions that are differentiable that you don't know how to find the derivative of? What do you think? Are there any, or can you find the derivative of any function that's differentiable? Like in terms of your knowledge, what you've learned in class already.
There's got to be another kind lurking in the background somewhere.
Nope. No, you know how to do I'll find out in the final exam, but if you truly understand the product, chain, quotient, and power rule, and I guess e to the x ln of x, and a few other things we've already done, then you know how to find the derivative of any function that can be written out if it is differentiable. You know how to do it. And nothing takes that long, right? If it's really messy, it might be messy to do. But regular old functions, they don't take more than a minute or two. Do you agree? To take the derivative? All right, now let me give you the bad news. And the great thing about this is I'm not the evil guy, because it'll be Bruce as the evil guy. And the bad news is it doesn't work that way next quarter. So if you want to find an antiderivative and you just randomly grab a kind of somewhat messy function, it's impossible. Okay, but nice functions, a lot of them you can find. So let's do some that we know how to do. Okay, so let's see, what is the integral of, how about x squared minus 5 dx? So that's the question. So what we need to do is we need to find a function whose derivative is x squared minus 5. All right. Well, you got to be careful. It's not taking a derivative. It's untaking a derivative. So for example, if I'm looking for x squared and I want to think about what is a function whose derivative is kind of like x squared. So the idea here is that when you take a derivative of a power of x, the power drops by 1, right? So if you go backwards, what do you need the power to do? Yeah, you need to add 1 to the power. So we can think about x cubed, but the problem is, what's the derivative of x cubed? Three x squared. Okay, and I get an extra 3. But we can deal with that extra 3 by just doing the following. Oops. We can take, has to be done this way. We can take 1/3 x cubed. And the idea is now when you take a derivative, that 3 comes down, and 1/3 times 3 is 1, and you don't have any extra numbers. And the power goes down by 1 to be an x squared, and that will work. Can you all see that that's derivative is x squared? Okay, now we need to find a function whose derivative is 5. I'm hoping you might be able to come up with that. Yeah, 5x. Okay, am I done? What do you think? Yeah, if you think I'm done, you lost a point. So we need a plus c. Plus c always happens when you take an integral. Just sometimes you could even start with that. Put the plus c and then start thinking. Because it's whenever you see an integral sign, you get a plus c if it's that kind of integral sign. Okay, how do you check your work, by the way? It's pretty easy. Yeah, I take a derivative. And I'll let you do that. Take a derivative and you get x squared minus 5. Any questions on that? So this is the beginning of thinking backwards. And again, if you can't think backwards, you will fail next quarter. Okay, I know you can all say the ABCs, right? A, B, C, D, E, F, G, H, I, J, K, etc., right? How fast can you say the ABCs backwards? Okay, it's a lot harder, isn't it? Maybe it's not for you, but it is for me. Z, Y, X, then W, then you see it takes a lot longer. Maybe not for you, but it does for me to go backwards and it goes forwards. So today is the beginning of going backwards. And next quarter, it's all about going backwards. Okay, so now let's do a theorem. And this is called the reverse product rule, power rule, sorry. And what that says is the following, very easy to write down. It says that the integral of x to the n dx is equal to, can you guess, based on our example we just did? So if you look at the x squared, that's the hint. See what happened to that one, and it's not any different really. Yeah, it's going to be not quite 1 over n. It's 1 over n plus 1. Okay, so it's going to be 1 over n plus 1 x to the n plus 1 plus c. Now, does that work for every n? Does it work for every n? Like I plugged in, if I plugged in 2, it worked, right? We got x cubed over 3, or 1/3 x cubed. If I plug in 8, does it work? Yeah. Okay. All right. It works for, you were close. It's not 1, it works fine. The integral of x to the 1 is x to the 2 over 2. Integral of x to the 0 is x to the 1 over 1. That works just fine. But it does not work for -1. For n not equal to -1. And in fact, for n equals -1, see if we can do that one. You better be able to. So let's go there. So we're going to take an integral of x to the -1 dx. And do not give me 1 over 0 x to the 0, because that doesn't work. But I bet you could tell me what it is. We can't use the reverse power rule, but you can tell me what it is anyway. And if I don't see in the chat box, let me put it in a different word. Can you think of a function whose derivative is 1 over x? And I hope you all can. Yeah, ln of x. But you missed a point. Plus c. Any questions on understanding these integrals or antiderivative? Okay. And this is called an indefinite integral. All right, so let me give you a big definition, and it's really notation of a definition than anything. And that is the following. You'll notice when I go like this, it's telling me I'm missing something. What have I not put in when I've been doing this integral that it wants me to do, that Google wants me to put in? It wants me to put numbers here, a and b. So let's put in a and b. So the integral from a to b is what we say of f of x dx is by definition. And when I do definitions, what I am going to do, just let me, is I do a triple equal sign to stress the fact that this is the definition. And this is f of b minus f of a, where I'm using the same notation in the other definitions. So in other words, you find the antiderivative, you plug in the number b, you plug in the number a, and subtract. So for example, let's see what is the integral from, how about 1 to 3 of 2x minus 5 dx. All right, so the way I calculate this, the way I figure this out, is I first just find the antiderivative. So what's the antiderivative of 2x? What function gives me a derivative 2x? Don't need the 1/2. Yeah, just x squared, right? Because it's 1/2 times x times 2x It's 2 times 1/2 x squared, and that's just x squared. Now, what's an antiderivative of -5? Yeah, 5x. And then I do the following. I have a symbol I use. Let's see if it lets me with these guys. Maybe this way. Let's see. Yeah, that worked. Oops, I have to go there. There we go. So the way it's done is like this. The 3 is a little farther left than it's a little farther right than it should be, but that's as much as I can do with this program. Is what you do is you write down the antiderivative, then you put a little vertical line segment. At the bottom, you put A, at the top, you put B. That's the middle step. Then we plug in. So now if we plug in 3, I'm going to do it in my head. Hopefully that's okay. 3 squared is 9, minus 5 times 3 is 15. 9 minus 15 is -6. Are you okay with that? A little bit of in my head arithmetic, but it's just arithmetic. Then I plug in 1. 1 squared is 1, minus 5 times 1 is -4. So we're going to go minus a -4. Because we do f of b minus f of a. Now, -6 minus -4 is -2. And there's my answer. Any questions on this? So the above is called a definite integral. So a definite integral means you have a number in the bottom, number on the top, and you do f of b minus f of a. An indefinite integral means that you don't have any numbers to plug in, and you just do your antiderivative and you put the plus c. You don't need a plus c here, because if we put the plus c, we'd have a plus c, and then we'd have a minus plus c. The c's go away, so it's just a waste of time. So in the end, there's no plus c. Anyone lost? Anyone lost? And this is totally new, but this is what next quarter is doing. Okay, I'm making it look easy. I want to give you a big warning. Okay, so for example, I'm not even going to write it down because it's too hard, but even though it won't look that hard, if I wanted to say the integral of sine of x squared, can you come up with a function whose derivative is sine of x squared? Where the squared is on the x, not on the sine. And if you think you can, then you're doing what you shouldn't do, and that is drinking a lot in the morning. Because the answer is no. You can't come up with a function whose derivative is sine of x squared. Okay. It turns out there is such a function. No one knows what it is. They've given it a name, but there's no combination of any function you've ever seen that gives you sine of x squared as a derivative. Okay, whereas, as I mentioned, we know how to take the derivative of every function, but antiderivatives are totally different. Any questions on that? Any questions? Okay, I see what you said. I lose a point, but now you see I didn't lose a point. Because with a definite integral, you don't need the plus c, only the indefinite. Okay, now comes the most important topic of maybe all of mathematics. But we're spending 5 minutes on it. But if you go on to do a whole lot more science and math, you'll be doing this all the time. And these are called differential equations. Oh, you know what? Before that, I think I should say one thing, and that is, let me do a properties. Okay, and this is going to work whether I have an indefinite or definite. I'm going to make it indefinite just for fun. And this says the following. It says if we take the integral of a times f of x plus b times g of x dx, then that's equal to the integral. Oh, sorry, it's equal to a. Let's do it. Times the integral of f of x dx plus b times the integral of g of x dx. So what it says is that if you have an addition problem inside the integral, you can split it up as two integrals. And if you have a number multiplied by a function, you could pull that number out. This is the same as the property for derivatives, right? You take the derivatives and then you add them together at the end. So same thing with integration. The proof is it works because derivatives work. Okay, and I want to give you a warning. If we had f of x times g of x, you cannot split them up, just like you can't split them up with derivatives, right? With derivatives, there's a product rule. Okay, and by the way, if you have f of x divided by g of x, you can't just split them up and divide the integrals. Okay, and in fact, there isn't even a quotient rule. It's just evil. Just let you know that. Okay, if you have some messy rational function, boy, is it hard to integrate. So you can't do the tricks. But with addition or subtraction or multiplication by constant, you can do it. Any questions on this? Okay, now comes a very, very important definition. And this is, again, I took many classes just on this and spent 3 years just on one example. Okay, and that is the following. Okay, it's a very simple definition, but it's really important in the world. And that is a differential equation is, and it's going to be very obvious, an equation that involves derivatives. Do you agree that was a simple definition? So when you hear the word differential equation, by the way, if it's an equation, what symbol must it have? It's not a trick question. Yeah, it has to have an equal sign. Okay. All right. So it has to have an equal sign and it has to have a prime or a d over dx or d over dt, something like that. So it has to have those two things. And if it involves those two things, then it's called a differential equation. Okay, where do differential equations come up? All right, maybe I'll tell you, everywhere. So for example, chemistry. Okay, chemistry and physics, all over the place. Have you heard of the Schrodinger's equation? Have you heard of that? That's a differential equation. Too hard for me to even write down. It's a really hard differential equation, by the way. Have you heard of exponential growth? That's a differential equation. Have you heard of circuits? Like if you have a circuit with, voltage and current and that kind of stuff, all that's related via a differential equation. Pretty much anything you think about is related via a differential equation. Okay, if you're even talking about velocity and position, that's a differential equation because the derivative of the velocity is the position equals the position. That's a differential equation. Okay, everything basically is a differential equation. Okay, my differential equation, by the way, what I did was look at long-term wave travel. So for example, in the ocean, who cares about that? Who puts in huge amounts of money into that? Anyone know? The military. Because if you can understand my equations, then you can figure out using the differential equations and the solutions where the submarine of the enemy is. And is it a submarine or is it a whale? So it was definitely sought after my differential equation that I did by the military, because based on my differential equation, they were able to detect they were able to take submarines on the other side of the ocean. It's so important, differential equations. Okay, I can go on and on and on. If you look at recognizing exoplanets, do you know how that's done? There's a differential equation. And that's because, again, we're looking at forces. And when there's force, there's a differential equation involved. And everything you do in science basically needs a differential equation. So I can't say too much about it because this is just first quarter calc. We have an entire course and it's sixth quarter calculus. So if you stay at our college, and this is a community college, do you know what the title of that course is?
Is it differential equations?
Exactly. So we have a whole course on differential equations, and I teach it often. Okay. So, and Bruce, it's either me or Bruce teaches it. So if you stay in, say, engineering, then you stay here for 2 years, you'll have either me or Bruce for the differential equations class. Okay. And it's something that's called ordinary differential equations because it's the easy ones. It's community college. And then you can take more advanced ones. So just let you know, this is so big a topic. All I'm going to tell you is it's big. I can't go into the details because courses and courses and courses based on it. Okay, but I can give you an example, a nice example. Let's suppose, I'll just write this down. Solve the following differential equation. So as I mentioned, a differential equation has to have two things. It has to have a derivative. So I'm going to start with the derivative. dy over dx is equal to 2x minus 3. And I'm going to do what's called an initial value problem, which means I also give you an initial value, and that allows you to get the plus c, such that y of 1 equals 5. So it's called an initial value problem. And that means you have a differential equation and you have an initial value. Sometimes initial is y of 0, but it could be anything. All right, well, these are the easy kind. Again, this is day one. Day one of many quarters if you want to keep going into it. Okay, so if you want to be able to come up with the solution to this differential equation, then we just read it and think about it. This says the derivative of a function is equal to 2x minus 3. Well, if we know the derivative of the function is 2x minus 3, how do you find the function? In one word. And you have a choice of 2 different one words that we've had in this class today. Yeah, so one of the words is antiderivative. And what's the other word? It means the same thing. Integral, okay? And in fact, it's such an important word. It even has tenses and stuff. So I could integrate. That's the verb for integral. So again, it's that important. So I'm going to take the integral, or I'm going to integrate. 2x minus 3 dx. We don't have an a and a b, do we? It's not 1 and 5, by the way. Don't get that confused. All right, well, hopefully you can all do this. What is the integral of 2x minus 3? Okay, I want to let you know, by the way, I call this the 4-point C instead of the 1-point C. You know what that means? So we got x squared minus 3x, and you forgot the plus c. And in this case, this is what I call the 4-point C. It means you lose 4 points. And the reason that you'd lose 4 points instead of 1 is we're not done yet. We're not done yet because we haven't used the y of 1 equals 5. So the y of 1 equals 5 is going to get us our c. So that's why it's a 4-point C, because that's like almost half of the process is to find the c. So the next step is to find c. So when I write y of 1 equals 5, this is very important. It's something you've had before calculus. We have 1 and we have 5. Which is x and which is y? This is not calculus. This is algebra. Which one represents x? Which one represents y? Yeah, x is the 1, y is a 5. Very important to know that. So now what we can do is we can say, well, y is 5. So I can put a 5 for y and go equal. And then x is 1. So I go 1 squared minus 3 times 1 plus c. Any questions? Any questions on using the initial value to get this c? Okay, now it's basic algebra. So now 1 squared minus 3 times 1, that's 1 minus 3, which is negative 2. So what must c be? Yeah, c is 7. So now we can write down our answer. So the answer, actually the easiest thing to do is copy and paste. Get rid of the integral part. Is y equals x squared minus 3x, and then c is 7, so plus 7. How do you check your work, by the way? Yeah, you do two things. One is you take a derivative, and notice if you take a derivative, you get x squared, you get 2x minus 3. What else should you do? Yeah, you plug in, not values, value, 1. You plug in 1, and if I plug in 1, I get 1 minus 3 plus 7, and that's 5, and it works, and you smile. Any questions on solving this differential equation? I want to give you a major warning. Okay, did I make this look pretty easy, by the way? Was there anything hard? Okay, hopefully nothing was too bad. Okay, it's new to you, so it might be, it's hard for me to know exactly. But if I took that 3 here and made it a y instead of a 3, good luck. And this is such a minor little change, right? If you had dy dx equals 2x minus y, good luck. Okay, to do that, you're going to need to take 6th quarter calculus, the differential equations class, and then you'll learn how to do it. Okay, but that's not going to happen for a long time because it's a lot of work. And it's just such a minor change. Okay. And then if I made it a little tougher with more than 2 variables, that's what took me 3 years of my life. Just one differential equation. But again, it was an important one. Okay. And it was so important, not only the military use it, by the way, it also saved lots of lives. Because when there was this big tsunami in Japan, I don't know if anyone knows about that or remembers it if you're old enough. And it killed a lot of people in Japan, but there was enough time between when the earthquake happened and when that wave got to the United States that they were able to use my differential equation solution to figure out what beaches to evacuate. Because they were able to say, based on the wave travel from what had happened, we need to evacuate these beaches, and they got it right. And nobody died in America because of the big waves that happened from that giant earthquake. Unfortunately, I think 20,000 people died in Japan. It's very sad. Okay, so I feel good about that. That was my, nice contribution. And I killed a lot of people probably too because of the military, but they were the enemy, so maybe it's okay. I don't know, but I don't know anything about it because they don't tell me. They just use my equations. Okay, any questions on this difference equations? All right, so what should we talk about now? Hopefully you all know. Yeah, the exam. So what I want to do is I want to go to syllabus. I think that's here. Yep. So I want to talk about the exam. There's not a whole lot to say other than tell you what you probably already know. So let's go into the syllabus, and hopefully some stuff you should already know, and that is the exam is on November 20th, and hopefully you do know that's Friday. Okay, and the exam happens at the same time that you took the last exam. So for most of you, that's 8:30 to 10:15. So plan on it. Do not go onto Zoom beforehand, because one, I won't be on it. The other is sometimes that destroys your computer with Proctorio. So in fact, you want to close everything except the exam so that your computer doesn't overload. And besides that, Proctorio won't let you have other things open. Okay, so that's just a big note, is that there is no lecture or anything like that. There's no other quiz that you have to do, or I'll be checking email basically if there's anybody that has big issues. The good news is the exam was not like yesterday or today, then I would have been really scared. Do you know why? You should all know. Huh?
Power outage because of the snow.
Yeah, look out the window. Yesterday, man, I hadn't seen wind like that in a long time. And the amazing thing is I didn't lose power. I don't know if any of you, but I would have been very scared had it been yesterday, because it was like brutal weather-wise. But the good news is the weather report is nice.
Larry?
Yeah.
I almost lost power during the quiz today at the last minute, but luckily I stayed on the page, and when the internet came back on, it submitted but late, but I was so close to just have power go off at my house because of that.
Yeah. Well, the good news is Friday the weather's supposed to be sunny. Okay. That's no guarantee, but the power usually doesn't go out on a nice sunny day. On today, we got lucky. We got pretty lucky where we haven't had a power outage during class. I think I've lost a couple hours of power this quarter, and fortunately it was in the evening. So let's hope there's no weird things happening, but we should be okay. Should be okay. But again, don't overload your system. Make sure that you just have the exam, nothing else on your computer. Okay. The policy and all that is the same as the last couple tests, so you're used to that. I don't have to tell you. But let me go through the syllabus some more. And what I can do is, we took exam 2 at the end of October, and the beginning of November through today, in terms of the homework due, and that's what's important, is what the exam covers. Okay, so you'll notice, and actually, let's see. I think 11, actually this section was on exam 2, so not this one. No, this was, I think I called it second derivative test, but it really wasn't. 4.3. It really covers from here to here. Okay, but just notice when we went into 4.5 was really the second derivative test, and first and second derivative test. So you still need to know that. So you'll notice there are, not that many different sections. So guess what? You can have a problem on Rolle's theorem and mean value theorem. You can have a problem on curve sketching. Because it's Proctorio, I can't have you sketch a curve, but you're gonna have to be able to do stuff that gets you ready to sketch a curve. You're gonna have an infinite limit problem. You're gonna have an optimization problem. You're gonna have a L'Hopital's rule problem. You're gonna have a Newton's method problem. Also a true-false problem. Okay. So it's pretty much one of each. There's sometimes an A and a B because, and for example, I could give you an A and a B, or maybe an A, B, and C with Rolle's theorem and mean value theorem. Make sure you understand both. Does that make sense? Curve sketching, you have to know the first derivative. You have to know the how to find the relative min and max. Yeah, sorry, how to identify critical points, how to find the critical point using the first derivative test, and how to find the critical point using the second derivative test, right? Increasing, decreasing, and things like points of inflection and concavity. So you should know all that stuff. Okay, I can't ask you all of it because it would take too long. And I know time is a problem for some of you. So I try not to make it too long. Okay, then of course I'm going to have you do a limit. That shouldn't be surprising. I'm going to make you take a limit as you go either infinity or negative infinity or towards an asymptote. You're going to have a word problem that involves optimization. Any questions on that? Let me see something. Oh, that's fine. Okay. You're going to have a problem. You're going to have some parts, different things to do with L'Hopital's rule. So there were different forms of L'Hopital's rule with 0 over 0, infinity over infinity, 0 to the infinity. Do you remember all these? 0 to the 1, 0 times infinity, infinity minus infinity. So again, I can't give you all of those because it would be too long a test, but I'm giving you a couple of them. I'm not going to tell you which ones. Okay, very standard, and you have to know what to do. Okay, you're going to have a Newton's method problem. There's not a whole lot of flexibility on that one for me. Guess what I'm going to have you do? Should be obvious. Come on, we just did Newton's method.
Find a root of a function.
Yeah, find where an equation equals 0. And I could ask where is f0, or I could ask for critical points. Same thing. Okay, then you have to take it f prime first. But very standard. Can get a little messy. I did put in the calculator that you did on Friday. Remember that? On the problems that you need it. You might guess Newton's method. You need a calculator for. Okay, it's just always calculations for Newton method, right? And there could be others where you need a calculator. Okay, and what I did is I embedded it directly into the problem where you need it. And if I didn't have to do anything more than basic multiplication, like 1-digit multiplication or addition and subtraction that was 1 or 2 digits, then I didn't embed a calculator. Okay, but if you need to find e to the 7 or something, absolutely. I don't expect you to do that by hand. So I embedded the calculator. You seem to like it. I thought it was, again, I don't even know what Proctorio's calculator looks like, but you guys seem to like it better. So I went for it. So hopefully you like it. That's all I can say. It's so weird they don't let instructors see the Proctorio calculator. I don't quite get it. Maybe you can tell me why if you like know someone who works for them. Any questions at all on the exam? Okay, just a big note. They don't want you to know how bad it is. Maybe that's it. Yeah. So just a note, after the exam, I'll grade it. Okay. Hopefully, but not guaranteed, have it graded by Friday. It does take time for me to grade because, especially with the online thing, because I got to type in all my comments. That takes a lot longer than writing them on paper. But there's a good chance I'll have it graded Friday. If not, it'll be graded by Saturday. And then next week, nothing. There's nothing due. There's no webinars. I'll be checking email if you want to like say hi or something. I have an extra homework assignment for you though, for next week. And it's a homework assignment that is due Thursday night. So a week from tomorrow night. And that is you must gain weight. Because that's being, patriotic. Eat a lot on Thursday night. Because that's what you're supposed to do on Thanksgiving, right? I could say you're supposed to go to a big party with your family, but I can't say that this year. But I can still tell you to eat. How's that? Okay, so again, we don't have any class at all next week. Okay, Monday, Wednesday, or Friday. So the next time we will meet on a webinar is a week from Monday. So we're talking 12 days from today is the next time we'll meet. Okay, just a note. I do have office hours today. I have office hours tomorrow. Oh, one more thing, because this probably won't matter to you, but there's a chance I'll be off my office hour a little bit on Friday. But you'll be done with the test with a week of vacation. Hopefully you don't need my office hour. I'm giving a presentation to our college academic senate. It's all the faculty. I don't know if you noticed, but you notice we don't have web pages. There's no faculty web pages. Like if you want to go look at, my web page, there isn't one. Do you notice that? So I am making it happen. So it's not a calculus thing. But all the faculty are going to have, all the full-time faculty at least, are going to have their own web page. And that's what I'm doing is I'm presenting it. So if you miss me at my office hour, then that's the reason, because I might have to be presenting. Okay, but you'll be done with your test and partying for Thanksgiving. So most of you won't need me. Any questions? Any questions about the exam, what to expect? What should you do to practice?
Redo the quizzes.
Yeah, redo all the quizzes. Because remember, I wrote those problems in Proctorio, kind of like pretend you're on Proctorio when you do it. As in, like, don't go out and, do searches on videos and stuff. Please don't do that because you don't get to do that in Proctorio. So, and make sure you type out the answers because that's important, because that's what you'll be doing. So redo each of the quizzes that happened since the last exam. What we talked about today is not on exam 3. So you will not have to do an antiderivative because I don't believe in testing you on something you haven't had homework yet. So just note, but it will be in the final. Okay. So redo your quizzes. You can always go back and look at the homework again. I have to check and make sure I've got to rechange all the dates. So I have to do that and remember to do that. But if you can't get in, let me know and then I'll do it immediately. Let me unshare. And hopefully it goes well. I'm going to go into office hours now.